Okay, and I'm ready as soon as you guys are ready.
I am ready.
My computer is telling me to log in again, but it's not letting me log in. So to log into the iLearn.
I
Oh,
hate Learn.
I do too. It wouldn't let me in on Tuesday night, and I had some stuff I really had to do, and I was like, ah.
Drives
Yeah.
me crazy.
Well, and they're changing it now too.
I know. I think that's why it's been so bad this semester too.
What are they changing?
They're
They're
changing it to
changing it
Brightspace.
Oh,
iLearn's
to
switching
I
to a different program next semester.
got it. When I
I'm
did my
excited
associate's
about it
degree,
though.
I had to experience a changeover from like Blackboard to something else, and I'm just like, it's such a pain to when it switches over and to like learn the ins and out of the new system. It just takes a
For
while.
real. My
Yeah.
dad's a professor on campus, and he feels it too. He's like, you have to learn everything over.
Mhm.
Like, man, I didn't think about the professors having to learn everything.
That's true.
So it's
Yeah.
just stinks for all of us. But
Well, and like for you, Angela, are you taking classes next semester?
I just have two left, so I'm gonna have to learn a new system for just those two, I guess.
just two
Yeah.
classes?
So what's
Two classes
interesting?
and an internship, yeah.
Awesome.
Yeah,
Um,
fun.
what's interesting about that though for you is that so things are gonna all be due. So you know how right now things are due at 12:59 for you
Oh
and
yeah,
12:59 for me. Well, next semester it's switching, so everything is due at 12:59 Mountain Time.
that's terrible.
Yeah.
Oh,
That's really bad, actually, because I
Yeah.
do homework after I get home from work at night.
Yeah.
that
So there's a tab.
stinks.
There's a tab that they'll teach you about, but like if you ever have a question, just there's like a way to switch your what is it? There's a way to switch your time zone. So if you ever need help with that, just text me and I'll tell you because that's what my job is now. So
Oh, nice.
That's sweet.
yeah, so I just got a job, so I'm kind of doing that and everything else and
Congrats. That's awesome.
putting together. Okay, I think
Hard to get a
I'm
job
up
in
and
Rexburg.
running now.
That's awesome.
Yeah.
So that new system starts next semester, you said?
Yeah, so they started a few classes this semester with it, but next
Yeah,
semester
just
is when they
testing it.
officially start it.
Okay.
Hmm. So sweet.
Yeah.
All right, Shaylee, are you up and running now?
Yeah. Um, yeah.
Okay.
I'm,
I'll start, and then you guys can read the next two.
Okay.
So the correlation coefficient is used to quantify the direction and
So,
strength of a linear relationship, direction and duration of nonlinear, strength and reliability of the linear relationship, or the direction and strength of the nonlinear relationship.
wait, am I in the wrong spot? What lesson are we doing right now?
we're
21.
doing 21.
21?
Yeah.
Oh, wow, that's funny. I accidentally clicked on the wrong thing. Okay.
It's
We
it.
went on to next week's thing. Hold on. Save
Oh
for
no.
later. It looks very similar to what we're doing. That's
Oh,
good.
good.
So I actually looked this one up. So it's
It's
the
A,
direction
right?
and strength. Yeah. Okay.
Okay.
I'm gonna go
Yeah.
grab something really quick, but I can still hear you guys. I just
Okay.
have to. I'm like I wanted to eat something, so I just need to pour something out really quick, but I can still hear you.
Okay, you're fine. Angela, do
Okay.
you want to read 4?
Yeah. So if the correlation coefficient is negative, or when one variable increases, the other variable tends to increase, is unpredictable, tends to decrease, or is negative. So I would say decrease. C.
Right.
Okay.
That's what I would say as well. I'll read 5. It says the effect of outliers on the correlation coefficient is not significant. That's false.
I would also say that's false.
Okay.
Okay.
I don't
The
know if she's back yet.
correlation coefficient between duration and weight of Old Faithful. Wait. Got it.
Okay.
So I guess we'll have to pull open that file.
Yeah.
Oh, there it is.
What did you get for 4 really quick?
Before we said it's C, that the other variable tends to decrease.
Okay.
And then 5 we put false. And 6, now we're just pulling up the Old Faithful data. Wow, that's a lot of data.
Oh, yeah, that is a lot.
Is
Oh, wow.
duration going to be the X value? Hopefully.
All right. So, copy.
Because we have to take this and put it into the
Into that
Linear
chart. Yeah.
yeah,
Mm-hmm.
it's linear regression, right? Or is that
Uh-huh.
wrong? Yeah. Okay.
Okay,
And-
I've got it.
Are we trying to find R? Is that what correlation coefficient means?
Yes, that's R.
Okay. I have it
So
as well.
I have a number.
You guys can go ahead. I'm just
I-
putting it in here really quick, but
Okay.
Okay. So,
So
I
I
got
got-
0.901.
So did I. 0.901.
Perfect.
And
The
then number
covariance?
7 says the covariance of duration and weight of Old Faithful is. So the covariance is. Oh. Let me see.
Oh, is that the one where you times everything by, right? It's time, yeah.
Yeah, it's like the correlation coefficient and then times something and then times something else.
Mm-hmm. And in
But
the
it just
Excel sheet,
gives
it
it
just
to us.
has it.
It just gives it to us in this chart, right?
Uh-huh.
So it's 13.945.
0.9. Yeah.
for just
Oh, it
checking
says to one decimal place.
for R, you guys got 0.9. What did you get again? I got 0.901 for R.
Yeah, that's what we got.
Is that right?
Yep.
Okay.
Yay!
Yeah, I'm just making sure that I'm doing all of this right. Okay.
And then covariance, it's just rounded to one decimal place, so it's just 13.9.
Oh, it's just one decimal place?
That's tricky.
That is, I should make a note of that.
Well, he just said it in 7. It just says round to one decimal place.
Oh, in the parentheses, got it. Okay, yep, got it. All right, so for number 8, it says questions 8 through 13, associate the scatter plot with the correlation coefficient. Type the letter into the box. So for number 8, R equals 0.0. So
See, right?
What?
I think you're breaking up a little bit, Alyssa.
Oh. I think 8 is C. Is that correct?
That's what I was guessing too, because those look the most random, like unrelated.
Yeah.
Okay. So then 9, R equals 1.0 is positive, and 1 is the highest number, so it's got to be A, because that's a very straight line. The line of best fit, or whatever it is. Like, it's like a perfect line.
10 would be D, right?
Yes.
Yeah, I think so. I agree with that. And
And
then
then
11 is
0.5 would probably be B.
Yeah, that's what I would say.
And then negative 0.95 would be E.
Right. And then negative 0.6 is probably F.
Yeah. Makes sense to me. Okay.
Yeah.
So number 14 says, the correlation coefficient between score and confidence of the math self-efficacy data is blank. The correlation coefficients. Oh, so we need to look at our little chart.
We need to download another one, I think.
I think you just right-click on one of the points on the little graph, and then you just put add trend line. Does that help at all?
Oh, but it's talking about self-efficacy data now. It's different, I think.
Oh, I see. So there's another file you're saying?
Mm-hmm.
But
Mm-hmm.
I have Old Faithful at the bottom of my thing as an attachment. Do you have the math one as an attachment?
No, I just found
No, but I
it
have.
in the textbook.
Okay, so it is in there.
That's what I did.
Yeah.
Yeah, you just have to go to the data files from the textbook.
Okay. There it is.
It's weird because this one, does you guys have like different like male and female stuff?
Yeah.
Oh, yeah. So how do we do that? Or do we not worry about that for this?
I don't know. I don't think we learned it, so we probably just don't worry about it, is my assumption.
So for this question, oops, so we're comparing the score and the confidence. Okay. So just those two. Weird. We'll probably just use that file again later sometime, I guess.
Yeah. Or maybe we already have used it.
Oh, that could be.
Okay, so I have both of the answers as soon as you guys are ready.
I'm like super close to getting mine in also.
Hold on.
So it's
Gotta
two.
delete the other stuff.
Um,
Okay, I'm ready.
yeah, me too.
So the first thing we need to find is the correlation coefficient, and I have. Oops. What is it? 0.729.
Me too.
Is that R? No, what?
Yeah.
Yeah.
It's R.
Yes.
I think I may have did something wrong because mine is not that. What did you get for yours? Oh, I know what I did. Hang on.
There might be old data left from the last question because there was a lot more information in that one. Did you clear it out all the way?
Yeah, I did. That's weird because I got. Let me see. Oh, I didn't clear it out all the way. Oh, weird. Anyway,
Oh.
you guys can go ahead because I screwed this up.
Okay. So then for the covariance, I got 11.21.
I did too.
Okay, I'm gonna submit. We got everything right.
Yay!
Sweet.
That's good. Oops. Yes. Perfect. Okay.
How did you do on the last test?
We both got C's.
Okay.
Yeah.
I
Not
like.
as well
Do you
as
normally
I
get
did.
C's or do you normally get higher than that?
I normally get higher, but
I got higher on the first
This one
test, and I feel like this is similar to before on my second test.
Yeah, it was harder.
Yeah,
I feel like because I went to go like I studied a lot and then I got to it and I didn't recognize like any of the questions.
There were a few I was like, oh.
I agree.
Yeah.
For the second, oh, okay, never mind. I figured it out. Okay.
And I'm ready whenever you guys are with the next one.
I'm ready.
I am super close. You can start without me. I'm just making sure I do this right real quick.
Okay.
For
So the
actually,
first one, you just...
So,
Okay.
for the last, so for 15, because I'm just entering that in really quick, you had to round it to 2 decimals. So did you get 11.21?
yes.
Uh-huh.
Okay, just checking. Okay, we can go ahead to the next one because I have it open already.
Okay. So question number 3 says, given the linear
Okay.
regression equation, y equals 2.0 plus 1.5x, what is the y-intercept? Round to 1 decimal. So I think that's 2.0, right?
I agree.
Yeah.
Okay. And then what is the slope? Round to 1 decimal. So that'd be 1.5.
Uh-huh.
Okay. And then what is the predicted value of y when x is 16? So let me pull up a calculator.
I think I got 1. Is that right?
You already have an answer?
Mm-hmm.
Let me pull up a calculator because you
Because
do
16 times 0.25 is 4. And it's -3 plus 4. So that's 1, right? Not 7. It's like basic algebra, but I'm like,
so -3 plus 4. So it'd be -1. Is that what you're saying?
just 1, right? Because it's basically like saying 4 minus 3.
But that's a -3 for y.
-3 plus 4 would be 1.
Uh-huh.
Yeah. Yeah, that would be 1.
Oh, plus 4. Okay, yeah.
Okay.
Yep. Okay.
Okay. And
I don't know
back to
why, but
basic
my
algebra.
quieter. Like I'm having a hard time hearing you guys now.
Can you hear me better now?
Oh. I can.
I just
Weird.
had my laptop kind of like, I don't even know what kind of image we're getting right now of me. I had it just like close to my face. I wasn't even thinking that we're in a recording, so.
I don't even look at you guys like the whole time. I just listen
Yeah,
to
me
you.
too.
So it's okay.
Teacher's gonna get a really random view of me. I was like literally like this. So this is what the view was just of this like painting behind me. So
That's funny.
okay. Here I am. Alright. So make a scatter plot of the math self-efficiency data of the 3 data shapes introduced in the reading, which shape best describes the data. So luckily we already have that inputted into Excel.
Yep.
Yeah.
So we just have to look at it, and it is very jumbly.
I would say it's probably the hot dog shape, though.
I would
Yeah,
too.
for sure.
Okay.
It's still
So
pretty
based on...
flat. It's not curved. Sorry, go ahead.
It's okay. Do you want to keep talking about it?
Oh no, you're fine.
Okay, sorry. Based on the shape of the scatter plot you produced in question 6, what can you say about the appropriateness of using simple linear regression to model these data? Simple linear regression is not appropriate for these data. If simple linear regression is used for these data, the results will not be reliable. Simple linear regression is appropriate for these data.
I think it's B. Like, you can use it because it does have that line. Like, it is a positive correlation, but I
Mhm.
think since they're so scattered that it won't be accurate.
I could go for that.
But maybe that just means it's not appropriate. I don't know. But since it's a straight line, then I think maybe it is.
Yeah, well, it's not super scattered like the hamburger,
Right.
so it's definitely a linear pattern. But I don't know.
I'm just gonna guess B,
There's not a way.
but it might be A. But since it is hot dog and not hamburger, I think that it's just not as reliable, but you still can use it.
Okay, I could go for that.
Okay. How many observations are in okay, how many observations are there?
Uh,
What does that mean?
Does that mean like the data? Like how much?
Does that mean like 70 or could
So that would just be N, right?
it would just be what?
N, like our sample size.
Probably.
Because it's 142.
But you have to think at the top, the first 3 lines are just setting up the table, so you have to subtract 3. It doesn't start till 4.
Oh, that's right.
Where are you guys? Oh, you're looking at 4. Okay, I see.
So
what you're saying.
142 minus 3, so 139.
Yeah.
Yeah.
Is that really what it's asking? That seems weird.
That's a weird question, but I don't know what else it would be mean by that.
Let's see.
Does it mean like how many? I don't think it would actually do that. Yeah. I was wondering if maybe it was like the number of dots, but
But
I
a
think
dot
that would
will
be the number
represent
of dots. Yeah,
A
so
number of
139.
yeah.
Huh, how weird.
Okay. That is interesting.
Do you want me to go on?
Yeah.
Use the math self-efficiency data to answer these questions. Be sure to use the confidence data for the explanatory variable and the score data as the response variable. So
We need to switch them.
that's what it's saying.
Of course they would make us do that. Is there an easy way to do that?
Just copy and paste.
Okay.
That's what I'm gonna do.
So confidence is our X now? Is that what it is?
Yeah.
Okay, I think I have it.
Maybe it was a little.
Okay. So we have to find the
y-intercept.
so what's the y-intercept?
I think it is 18.559.
Okay. That's what I have too.
Yeah.
And then is the slope 12.725?
Yes.
Okay.
Your answer should be exact. What does that mean? Does that mean just put
Use all the numbers from the answer it gives you in the chart,
okay.
however many decimal places that is. So no rounding, I guess.
Okay.
Okay, so what is the predicted value of y when x is 4?
So this is in the Excel thing, right? It's just, you just have to put the x variable for 4.
There. So I got 69.459.
Me as well.
Where did you put that at? Oh, so because it says X and then underneath it says 6.
Yeah, you
Yeah.
just change it.
It's
So
the
change
like
it
the blue
to 4.
shaded box. Yeah. Because
And
x
then
is
we have to
4.
find the predicted, so it's 69,459.
Uh-huh.
Okay.
Okay, 12 says the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Hint, because there is a positive correlation, we can use the largest x value to find the largest predicted value of y. So I don't really understand what it's asking.
So in our chart, we look for the one that's farthest on the x-axis. So I think that is 5.93 and 97, right?
That's what I've. That's
Do
what I
you see
have
what
too. I think.
Where did you find that at?
You just have to hover over the bullet on your graph.
Oh, well, there's a 6 and a 93, so it might be that one. I think it's 6. Oops.
697. I have 697.
You have a 697?
Yeah, I have 697.
How do I get rid of the trend line? I have a 693.
What does that mean?
I don't have a 697.
Move your key or your mouse just a little to the right. And a little bit up, maybe.
Okay, there we
Then
go.
you should find it.
697.
So it would be 97.
So that means it'd be 97. But that doesn't seem like a very accurate way to do it.
No. Let's see.
So I wonder if it's better to just look at the chart and like, I have an idea. Let's sort.
What if you, so you know how we had, we changed X to 4? Wouldn't you change that back to 6 and then prediction interval for Y, it tells you what that is?
Oh, and it'd be 94.909.
Well, you have to change X to 6 and then you have to enter. Oh no, I know what you're looking at. No, so if you see it says predicted, go all the way down to predicted interval for Y.
Oh, okay.
2 answers. So there's 72.365 and there's 117.453. I don't know which one we would pick,
I
but
don't know if
I think, yeah, I don't know.
maybe. Because it says the largest predicted value of
it would
y.
be 117.453.
It might be. I don't know. It's either going to be that or it's going to just be. Well, it has to be that because that's for y. I was going to say it's either that or the predicted like 94.909, but I don't think that would be it.
I feel good going with the 117.453.
Let's see what happens. How do you find 13?
6 is our highest number.
What was that?
How do you find 13? Are you
The
guys
six
okay with
highest
doing that?
numbers on the- Sorry, yeah. I was just making sure the value.
Oh
And
yeah,
it is.
yeah. The
Okay.
x value is 6, and then 117.453.
I don't know how to do 13 and 14.
So I think number 13 is it says how many explanatory independent, so how many variables are present in this simple linear regression. I believe it's only one, because that's going to be your x variable. Like if we were comparing like that third column with male and female, then we might have two. But since it's just like one set of variable, like it's only two variables, one on each axis, I think that it's just one independent variable.
So you're saying that it's just like confidence is the variable.
Yeah, so one of our variables is
So like if we were
one
splitting
is
it up into
confidence and
male
one is
and female?
four. And so one is on the x-axis and one is on the y. One's dependent and one's independent. But if you were comparing three things together, you'd have two independent variables.
Okay.
So I submitted those, and 13 and 14 are both 1.
Yeah, that makes
But
sense.
we got 2 other ones wrong.
What did we get wrong?
So 7 is wrong. 7 is supposed to be simple linear regression is appropriate for these data.
It is appropriate?
Yeah.
Okay.
And then 12 is wrong, but it doesn't give me an answer to what it should be.
I'll try 97. We'll see if maybe that's it.
Okay.
And then you can wait, Angela.
Okay.
It looks like it's still wrong. So I don't know how to do that one.
Is the maximum predicted value of y for these value of x? And 117,453 was wrong?
Mhm.
Ah.
You could maybe try 94.9, or you could try 72.365, or you could even just try 117 without the decimals, but
I'm trying to see if there's like anything in the lesson. I bet you it's 94.909.
I think so too. 94.909. Okay, I'm going to submit and I'll let you know if that's right.
Okay.
Oops. Yep, that's right.
Cool.
okay.
So you just have to put in, you just
So
use
it's
the
just
predicted.
the one under predicted,
Cool.
which is weird that it has a prediction interval for y down at the end. Then.
Yeah. That is weird. Well, cool. Nice job, guys. We did
You
that
did pretty
fast.
well this week.
Yeah. I hope this
Do you
just
have any
continues to
questions?
be easy.
Shaylee, we talked about the assignment that's due on Saturday a
Yeah.
little bit because Angela's in charge of being the main writer for it. But I was looking through it and it looks like it's a pretty big assignment. So I told her she could delegate stuff out to us if she needs help with it.
Okay. Yeah.
Basically, Angela, it's all on you until you tell us what we need to do.
And then I'll let you know tomorrow what I need help with, I guess.
Perfect. Sounds
Okay.
good.
Thanks,
Cool. I
guys.
think that's it.
All right.
Okay, yeah. We'll see you guys next week.
Yeah. All right. Bye.
Bye.